We will start a new topic.
Okay.
Energy and power. Okay. So in the previous topics, the chapter 3 was what?
Sorry, sir.
Chapter 3.
Yeah.
It's relating about one D motion, right?
Yeah.
So what are the interesting things you learned in the chapter? Suppose I just want to say some 2 points. What will you say according to you?
Differentiation.
What is the new thing you learned?
What is the
New thing you learned? Something interesting you learned?
sir? Calculus.
Okay. Distance.
Yeah.
Displacement. Distance equal to 0 and displacement equal to 0. This is possible, right?
Yeah.
Okay, what is an example?
Sir, an object traveling in a circular path.
Okay, but 1D motion, right?
Yeah.
Circular
For 1D motion, it is going from point X to point Y and then coming back to point X.
Okay. Another thing is the ball thrown vertically upwards and then coming down.
Yeah.
Okay. Right. What about the next chapter, 2D motion? Anything interesting you learned?
So projectile motion and uniform circular motion, that was new.
Okay, projectile motion was 2 lines defined plane, right?
Yeah.
So in projectile motion, what is the plane? The plane of motion is stated by what?
X and Y axis.
No. The direction of.
Oh yeah. Yeah. Okay.
Okay. Right. What about in laws of motion? Anything interesting?
Sir, that free body diagram and
Okay.
friction, that was interesting.
Non-inertial frame.
Yeah.
Pseudo force.
Yeah.
Anything else? Yeah, constrained motion. You watched that video on constrained motion?
Yes, sir. Actually, I didn't watch full. I think I watched half only because my battery died.
With just a 5-minute video?
Yes, sir. It is your video only now.
Yeah.
Yes, sir. I'll watch today after this class ends.
Okay. So new to this chapter, work, energy, and power. So what do you understand by work?
Force multiplied by displacement.
Okay. Energy.
It is the capacity of a system to do work.
Okay. Power.
It is work done per unit time.
Yeah, the rate at which the work is done.
Yeah.
Okay. So let us do some basics because we need some new sort of mathematics to handle this work done and all.
Yeah.
So vector algebra, what are the things you know until now?
Sir, vector addition, vector subtraction, cross product, dot product.
Okay. Okay, we already covered that. No? Fine. So you know how to add two vectors, subtract,
Yes, sir.
and then
Yes.
multiplication. It's dot product and cross product, right? What about division?
Sir, division is not applicable on vectors, right? Vectors do not follow division
Yeah.
law.
Division
I
is not
think. Yeah.
right. So yeah, for addition and subtraction, you have to use parallelogram law or triangle law.
Yeah.
Okay, and okay, for multiplying two vectors, we can use scalar product or vector product. And
Yeah.
scalar product of two vectors A and B is defined like this: A
Yeah.
B cos theta, where theta is
Hmm.
angle between A and B. Okay, so these are the two vectors A and B. Vector is denoted by this bold-faced letter in printed text. Okay, and the angle is theta in between them. Okay, so this can you can either interpret this as A into B cos theta,
Yes, sir.
or A cos theta into B.
Yeah.
Okay, so B cos theta you can understand like this: projection of B.
On A.
Uh, so dot
Yes.
product is A vector into projection of B onto A. Okay, or you can interpret
Yeah.
it as A cos theta into B. So that will be A projection of A vector into length of the B vector.
Yeah.
Okay, both will give the same answer.
Okay, sir.
So when theta is 90 degrees, the projection will be 0. Projection is 0, right? If you have two vectors like this, A, B, okay, the projection of B vector onto A is 0. It's only this much.
Yeah.
And similarly, projection of A vector onto B is also 0. So when
Yeah.
the two vectors are perpendicular, the dot product is 0.
Yeah.
Okay, you know unit vectors, right? I cap, J cap, K cap
Yes, sir. I know this.
along
Yes,
along
I know.
X, Y, Z axis. So
Yeah.
um, I cap is these are two vectors. So projection of this onto this, so it will be same, and the magnitude is one. So it's a cap. No, cap means
Hmm.
magnitude is one.
Yes, sir.
This is one into one, so it will be one,
Hmm.
and it is same as J cap dot J cap and K cap dot K cap, and
Hmm.
I cap and J cap are perpendicular, so
Yeah.
product is 0. So similarly, J cap,
Hmm.
K cap, and K cap, I cap.
Yeah.
Right? And any 3D vector can be written in terms of components Ax, Ay, Az along I cap, J cap, K cap. Okay, and let another vector B be written in terms of its components. Now A dot B is Ax, Bx plus Ay, By plus Az, Bz. Right?
Okay.
How do you get this one?
Um, Sir, by using the above mentioned I cap into J cap is 1.
Yeah. So basically, A
And
dot B will have 9 terms, right?
yeah.
Uh, and
So
out of
some will
9,
become 0.
yeah.
6
So
will become
6,
0. 6 will become 0. And 3 remaining will become like this.
yeah, 6 will become 0 because of this one.
Yes.
And
Yes, sir.
remaining 3 is this one.
Sin cross product, it is opposite, right?
Cross product, it is defined in a different way. A cross B is A into B sine theta, and then n cap, right?
It's yes, yes, sir.
No,
It is like
happy,
perpendicular to a plane.
yeah. So for that, you need to know determinants. So it's not done right now. You can do it later. Okay. So if you take a vector and dot with its own, then it will become A dot A, which is equal to this one. Like I can take a
Yes, sir.
number and multiply with itself, right? So it will become 25. So similarly, I can take a
Yeah.
vector and dot product with itself. So it will become ax square plus ay square plus az square. Okay,
Okay.
which is positive. Okay, and a dot b equal to 0 means a and b are perpendicular, or one of the vector is null vector, right?
Yeah. Okay, sir.
Null vector means the magnitude is 0 and direction is not defined.
Yeah. Yeah.
Okay. Now with the understanding of dot product of two vectors, we can define the work done by a force F as F dot D, where D is the displacement
Cos.
which is happening because of this application of the force. So work done is F dot
Yeah.
D, which is equal to F into D into cos theta, because D is along this direction and angle between F and D is theta. So it's F cos theta into D. So component of force along the displacement into the displacement. This is a better way to remember it. F dot D, after that, component of the force along the displacement into the displacement. Okay.
Yes, sir.
And the unit of work done is what?
Joules.
It's Newton into meter, which is represented as joules.
Yeah.
Force into displacement, right?
Yeah.
Okay. Now we define something called kinetic energy. Okay. So when you move a mass from rest to a particular velocity v by applying a force, then the work done is force into displacement, right?
Yeah.
And this force into displacement is over. That force may not be a constant force. The work done is F into F dot displacement, assuming the force is constant. But suppose the force is not constant, then we take a small interval dw in which the force is approximately constant, or F dot ds. In the small displacement ds, the force is approximately constant. So that work done in that interval is dw, which is F dot ds. After that, to get the total work done, you have to integrate dw between the limits 1 and 2. Okay. So the force, net force acting on the body of mass m is given as m into a by Newton's second law. Okay.
Yeah.
Right. Since the initial velocity is 0, the displacement will be along the direction of the force. Okay, because
Yeah.
initially it's at rest, so it doesn't have a tendency to move in any direction. And then you're applying a force, so naturally it move along the same direction.
Yeah.
Okay, so yeah, so there is no cos theta term here. So acceleration is dv by dt. Okay, so and then dx by dt is velocity. So you can rewrite this thing as this one. dv by dt dx as dv into b. Is this clear?
Yeah.
Okay, so now we can integrate this one, half v square. Integral of v is half v square. That you know,
Yeah.
right? Derivative
Yes,
of
sir.
x raised to the power n with respect to x is n into x raised to the power n minus 1. So when you integrate x raised to the power n minus 1, you get x raised to the power n divided by 1 by n. So when you integrate it, the power will go up by 1, and then you have to divide by 1 by n. Okay, and the limits are it's starting at rest. So v is 0 at x1 and v equal to v at x2. Okay, so this work done has gone into increasing the kinetic energy.
Yes, sir.
Okay, so the expression of kinetic energy is half mv square from this.
Yeah.
Okay. So yeah, that definition of work done is F dot into displacement if the work is, if the force is uniform. But in the case of force which is not uniform, there is changing from different point in space, we can define the work done for a small interval in the displacement. Say dx, that work done is F into dx, dw. This we are assuming that the displacement and the force are in the same direction. In general, it can be written as dw equal to F dot ds if it's along the x-axis dx into cos theta. Okay, we are assuming the theta is 0. Okay, so this is a plot of the variable force or non-uniform force as a function of x. So uniform force means how will it look? It will look like this, straight line. That's not the line. Okay, non-uniform means there will be some variation. So this is an example of non-uniform force. And for a small interval dx, this is approximately uniform force. Okay, so the work done in this interval is f into dx, and this vertical line is f, right?
And horizontal?
Horizontal is dx. This interval is dx. Okay, so the work done is coming out to the area of this element.
Yeah.
Okay, so the work done in moving from some initial position to the final position is summation of all these areas.
Okay. Okay, sir.
Okay, and the interpretation of integral of f of x dx from 1 to 2 is area under the curve. Like the interpretation of derivative is slope of the curve. Similarly, integration of a function is area under that curve. Okay, so the work done to move from x1 to x2 is integral of f dx from x1 to x2. Okay, here the interval is finite element delta x. And when delta x tends to 0, the interval will be very, very small. And this thing will become a smooth curve. This area will be exactly the area under the curve. Okay, so the work done is integral x1 to x2 of f dx. When the force is non-uniform. Okay, so work energy theorem. Okay, let us consider a body and apply a force F to it. So the velocity of it will change. So the kinetic energy at any instant is half m v square. Okay, and the time period of change of kinetic energy is d by dt of k, which is equal to m into p into dv by dt. Because kinetic is half m v square. So if you differentiate v square, you get 2v dv. So you get m into this one. And dv by dt is acceleration. So it's force into velocity. So it's force into dx by dt. From that, you'll get the increase in kinetic energy as force into displacement, which is equal to the work done. So the work done has gone in increasing the kinetic energy of the body. Okay, so this is the work done in moving the thing through a small displacement dx. So now if we integrate this thing from the initial position to final position, you get the total work done. That has gone into increasing the kinetic energy from final value to from the initial value. So the total work done is gone in increasing the kinetic energy. Okay, there is no other form of energy. There is a body to which applying force, and that force is doing the work, and that work has gone into increasing the kinetic energy.
Okay, sir.
Okay, try this. So, what are the forces acting on the block?
So friction and pulling force pulled by 100 Newton, that's written that.
Okay, and weight of the block,
Yeah.
and then the normal reaction. Okay, these are the four forces. So, and the displacement is along this direction, right? It's moving along this direction.
Yeah.
Okay, so the work done by the forces, normal reaction, the weight, how much is it? So, work done by
100 Newton.
Work done by normal reaction first. There are four forces, no? So you can calculate the work done by all the individual forces. So work done by normal force is 0
Yeah.
because force is perpendicular to displacement, right? And work done by the weight is also 0.
Yeah.
Okay, and this work done by F is F cos 37 into the displacement, which is equal to 5 meters.
So F is friction, right?
No, F is the applied force. The small f is friction.
Okay. Yeah,
F
yeah.
is an applied force of 100 Newton. So this is 100. How much is cos 37?
4/5. 4/5.
You have to remember this triangle. This angle is 37. This angle is 53. Angle opposite
Yeah.
smaller side will be smaller angle. So cos 37 will be 4 by 5
Yeah.
into 5. Work done by friction force is mu into N, right?
So it will be negative, right? I think. Yeah, negative.
Yeah. Because angle between
180 degree and cos 180 is -1.
180 degrees. So friction is 0.4 into mass is 10 kg.
1000 Newton.
No, no. Normal reaction is not mg. It's mg minus F sine 37.
Eh?
Normal reaction, the F component is there, no? Normal reaction is mg minus F sine 37 one is mg minus 100 sine 37 is 3 by 5, right? Okay,
Yeah.
so 100 into 2 by 5, 20, so is it 40 normal reaction? So mu is 0.4 into 40 into 5. Okay, so 16 into 5, which is equal to 80. Is it clear?
Yes, sir.
Okay. Okay, this one from x equal to 0 and moving to some distance. Okay, at x equal to 0, the force is 10 Newton. And after that, the force is 10 Newton for some distance. And once it reaches 5 meters, the force starts decreasing.
Okay, sir. I'm calculating just a second. Sir is work done 50.
Which one? He's asking for different regions. From x equal to 0 to 10 meters.
No, sir, it is not 50 for that. For that, it is 75.
How did you find the work done?
So I just calculated the area
Yeah,
under the graph.
area under the curve. Yeah. So from 0 to 10, it is 50 plus half into base 50,
25.
right?
So 75.
And this is 5. This is 10. So 75, yeah. And 10 to 15 is how much work done in this part?
-25.
Okay, so work done from 0 to 15 is how much?
10. Sorry, 50. 50.
Yeah. So why does the work done under the x-axis negative?
Sir, I think because force is acting in the opposite direction.
Yeah, see work done
In that,
dw is f into dx, right? So x is increasing x. So when I'm going from here to here, x is increasing,
yeah,
right? So this is positive. Okay, so the sign of the work done will be decided by the sign of f.
yeah,
Okay, so the work done in this small interval is negative. So in the next interval also is negative. So if you have all these negative areas, I'll get the total work done from here to here as negative.
Yes, sir.
Okay, this one. Assume this is the relaxed length, L naught. Okay, after that, I'm saying this way x0. So from x equal to 0, I'm stretching to x. Okay, and suppose I'm stretching, suppose if this x is s, what is the amount of work done in taking the spring from x equal to 0 to x equal to s?
S.
What is the
Sir,
work?
force formula.
Is it the variable force or uniform force?
Sir, which force?
See, we are trying to pull this, stretch the spring, right?
Sir, I think it is a variable force.
So what is the force expression? Force equal to what?
Mass into acceleration.
No. In this particular spring case,
Sir, I forgot.
it's k into x, right?
Oh, yeah.
This is property of a spring, and it's also called Hooke's law. Okay, and to be precise, it should be minus kx.
Which law?
Hooke's law
Okay.
is named after the person Hooke. Basically, the law says the force is proportional to x. Okay, and there is a constant. Proportional means it's a constant. Also, proportionality is there, no? And this k.
Yeah.
And minus sign is indicative of the fact that direction of force is opposite to the direction of the displacement.
Yeah.
Okay, so the force is this one. So how do you find now the work done is F dot displacement, right?
Yeah. Sir, is the work done minus kx square?
The thing is, see, it's a non-uniform force, right? So this is if the force is uniform. F dot.
Okay.
So
So
since
we have to integrate or something.
yeah, so we have to take a small interval, say F dot dx. Okay, and then you have to find F by integrating F dx. This is for uniform F. Okay, so now F is kx. Okay, and xi if you take it as 0, yes.
Sir, how?
Which one?
How will we take xi is equal to 0?
You're stretching this. See, the initial condition is relaxed condition, right?
Yeah.
Okay, relaxed condition corresponds to x equal to 0 because this force is the increase in the length from the relaxed position.
Okay.
Okay, it is not some, it's actually x is the stretching from the relaxed position. Okay, so only if I take x equal to 0 as the relaxed condition, that the force is carrying to x. From the relaxed position, whatever is the x, the extension, that is x.
Okay, sir.
Suppose if I say the relaxed condition x is x naught, then the force is not k into x, it is x minus x naught. Because x is the change in the length of the spring from the relaxed position. Got it?
Yes, sir.
So this expression is clear now, half x final square minus initial square. So this is
Yes, sir.
half k s square. That will be the work done in stretching the spring.
Okay, sir. Sir, can you explain me how you did the integration?
Integral of x dx. See, when you differentiate x square,
Yeah.
what is differential of x square?
X to the power n plus 1, so that is x cube by 2.
No.
No, x cube by 3.
D by dx of x square is how much?
2x.
So this means integral of x is x square by 2, right?
Yeah.
Integration is the opposite of reverse of differentiation.
Yeah.
So this is the result.
Okay.
In general, if you differentiate x raised to the power n, the power will go down by 1. Okay. So when you integrate x raised to the power n, the power will go up by 1. Here I'm
Okay,
integrating
sir.
x, the power is going up by 1. Okay. And it will get divided by 1 by n.
So that is 2.
Yeah. Because when I
Okay.
differentiate x square, I'll get 2x, no?
Yeah.
That 2 and 2 will cancel.
Yes, sir. Okay, sir.
Okay. This one. See, there is friction. Okay. And right. When you are giving it an initial velocity 20 meters per second, will it go up and stop somewhere?
Yes, sir.
What is it stop?
Sir, friction force is 50 Newton.
Okay. Suppose friction is not. Suppose this is smooth. Will it stop somewhere?
Yes, sir.
Why will it stop?
Gravitational force.
Yeah. So there are two
And
forces which are trying to reduce this velocity, right?
yeah.
And both the forces are acting opposite to the direction of motion.
Yeah.
Okay. So one force is mg, and there is a friction force here. So what is the component in mg down the plane?
Mg cos theta, right?
I told you so many times, it's mg sin theta.
Arey yaar.
Got it?
Yes, sir. Mg is 100 and sin theta, sin 37, 3 by 5, 3 by 20, 60.
So the net force
60.
acting in downward direction is mg, m is 10 g into 3 by 5 plus the friction force 0.5. What is normal reaction? What is normal reaction here? What is normal reaction equal to?
Mg sin 30.
Mg cos 37, right?
$80. Hello?
Yeah. Cos 37 is 4 by 5. All right. So changing this one plus 0.5. I'm going to simplify this one. 8G, right? So it will become 4G. This is 2. This is 6G, right? So now how will you find the distance it travels before it stops?
So we got the force, and force is equal to mass into acceleration.
Yeah. So you can get the acceleration.
Yeah,
F net 10G divided by the mass. Mass is 10.
yeah.
So acceleration is G. So from there, how will you find the distance traveled before it stops?
So we use that law of motion,
Equation of motion.
equation of motion. Yeah, sorry.
Which one? Which
H is
equation?
equal to vt plus half at square.
You don't know the time, no?
So v square is equal to u square plus 2as.
Yeah, whenever V is 0, usually this is a convenient thing. Here acceleration is actually minus and V is 0. U square is 20 square minus 2 into G into S. This is 20 meters. Got it?
Yes, sir.
Right. Do this one.
Sir, the 10 meter per second speed is final velocity.
Find the work done. No. It's falling down. No, so it will still continue. Falling down means initially it's at rest. Okay, and you're
Yeah,
reaching. It travels a distance of 20 meters. When it travels a distance
and
of 20
after that,
meters, it reaches a speed of 10 meters per second. Okay, and
that
there
is
is some
final velocity.
air resistance is there. So what are the forces acting on this ball?
Sir, gravitational force and air resistance.
Air resistance is upwards.
Yeah,
Okay, only these two, right?
yeah, only these two.
Okay. So U equal to 0.
Yeah, we have to find V.
V is 10 meters per second.
So that is after air resistance, right?
Yeah. So you can use this work energy theorem. Work done by all the forces equal to
Yeah,
change in kinetic energy. This is
okay,
all forces because everything is going to contribute to the change in kinetic energy of this body. Okay, so because of
okay,
mg, the velocity will increase, and because of f, the velocity will decrease.
yeah,
So the net combination, this will be a little bit less than the velocity due to mg only. If mg is the only force, then the velocity will be something, and because of f, it is something else. Okay, so right, so work done by mg is mg into the displacement, and work done by the friction force is F into 20 but minus sign because the direction is opposite. It's just force into displacement, right? It's a uniform
yeah.
force.
So mg is 50, 50 into 20 is 1000. Okay.
150 into 5. $75 by 2. What is asked? Find the work done. Oh, okay. We have found the. What
We
is
have
it?
to find F, right?
Okay, we have found the friction force. So the work done by the friction force is, yeah, we don't have to simplify this one. We just have to keep this one and then find the difference between the other two. Okay, so it's one. So this is equal to
750.
joules.
Okay, sir, understood.
Right. So work done is negative in the sense like direction of the friction force and the displacement are different. So the friction
Opposite.
force in negative work means it is taking out some energy from the body.
Yeah.
Okay, if a force does work on the body, then it is supplying energy to the body. And here,
Yeah.
the only form of energy is the kinetic energy. Okay,
Hmm.
so the friction force is taking some work from the energy from the body, so it's decreasing its velocity.
Yeah.
Okay, so that decrease is indicated by the negative sign.
Okay, sir.
Okay, all right. Uh, okay, in the previous this thing, chapter 3, 4, 5, how much of Allen sheet you have done?
Sir, I think Newton's laws of motion I had completed fully.
Okay, everything is clear.
Yes, sir.
That last time I did one wedge sliding on an inclined plane. No, on top of the wedge there is another block which is vertically moving downwards.
Yeah.
Remember, I forgot. Any difficult problems in that one? In any of the exercises?
So there are difficult problems, but we had discussed in class only, so that is clear now.
Okay. Uh, right. So in the coaching, what they are doing in physics?
So now we have completed integration, so I think we'll be starting with kinematics.
Okay. Did they give any sheet for this mathematics, basic mathematics?
Sorry, sir.
Did they give any sheet for this maths, basic maths?
Yeah. Yes, sir. They have given for derivatives, that is differentiation. They've given. I will share with you also.
Okay. Is it difficult or?
It is first it is easy, then they go little difficult. It is like like it is not word problems. It is only they have given some values and we have to differentiate.
Okay. What about the math sheet? Is it difficult, same level as compared to Allen, or it's more difficult?
So it is same level, I would say. He has said to solve from books Engage. Maths teacher has said to solve from books Engage.
Engage you have or what?
No, sir, I have PDF.
Okay.
So in that book there are difficult problems. So yeah, it is difficult.
Mhm. Okay. For physics, they have said any book.
H.C. Verma.
HCM is not a difficult book. It's basically to get the concepts clear. Okay.
Yes, sir. Now, till now he said only H.C. Verma, and for difficult problems he is sending sheets.
Okay. Right.
And sir, maths, have you finished complex number chapter?
Complex number chapter. No problems. We have done only one class. No, we have to do
Okay.
some more, and we have time because we have finished 5 chapters. No,
Yes, sir.
our estimate is 2 chapters per month. We have finished only 1 month, so we can solve some more problems in this complex numbers because we have to solve because difficult problems we are not touched.
Okay, sir.
This problem is saying, see, the interesting thing about this whole problem is this block A
Yeah.
is vertically moving downwards with respect to the earth frame.
Yeah.
That's
Okay.
important. With respect to the earth frame, it is vertically moving downwards, and this B is sliding down. Okay. So to maintain this vertical movement, A has to slide in this direction because
Okay, sir.
so it is sliding in the right, sliding with respect to B, but it is with respect to ground, it is just vertically moving straight.
Yes, sir. Okay.
That is the interesting aspect of this problem. Fine. So okay, we'll meet tomorrow. Is it difficult or easy?
Sir, actually, in chemistry, there are many new concepts like quantum mechanical model of atoms. So it is like it takes time to understand that, but after you understand it is easy.
Okay.
Numericals are less and theory part is more, so it is easy.
Physical chemistry is okay. It's more like physics and logic and those things. Organic and inorganic, you have to remember a lot of things. But for chemistry, NCRT book is the main thing.
Yes, sir.
If you are thorough with NCRT book, then you are in a good position.
Okay, sir. So
NCRT
you have
book,
taught them.
no, chemistry I don't know.
Okay.
Physical chemistry I can manage, but chemistry I have not touched it at all. I'm just concentrating on
Okay, sir.
this one. And NCRT PDF you can get from Byju's website.
Sir, I have NCRT.
Okay, NCRT is important for chemistry. Okay, we'll meet
Okay, sir.
tomorrow.
Okay, sir. Thank
Bye.
you, sir. Bye. Namaste.